In the set questions for our Unit 3, Lesson 4 video, we are first asked to graph the explicit function h of t, defined as 2t minus 5, and find the indicated values. We've been practicing finding values of a function, and so we can either evaluate h of t at some values, or we could recognize that this is a linear function in the form of y equals mx plus b. So our ordered pair 0, negative 5 is our y-intercept, because b tells us what our y-intercept is, and our slope is 2, and we could think of that as a constant rate of change, and I could remember that 2 is the same as 2 over 1. All right, so on my graph, I want to come down to negative 5 and put a nice point there on the y-axis at 0, negative 5. And then I could use my slope by going up 2 over 1. And I could continue to do that, or I could go back down 2 backwards 1. After I get a few good points, though, I could also just use a ruler or straight edge to connect those. And you want to make sure you do that with precision. It's really hard to do on my digital one-note ruler. Sometimes it's a little bit disagreeable. All right, so this line I drew represents all of the solutions for h of t that we could see in the graph provided. Now we're asked to find indicated values. So we could use our graph to help us. We could also, though, plug these things into our function. So for example, when I'm finding h of negative 4, remember that's when t, which is on our x-axis, is negative 4. So if I'm looking at my x-axis, I go out negative 1, 2, 3, 4. And it looks like it's just off the graph. And also, I'm noticing my points got a little questionable right here. So I know it's a negative number. I think it's probably negative 13, but let's check by just evaluating the function h. So we could have graphed this way as well by coming up with points on our function h. When I substitute negative 4 for t, I get negative 8 minus 5, because remember, when I'm evaluating, I want to follow the order of operations. So we evaluate this way, we solve going backwards. So I'm going to multiply before I subtract, and then negative 8 minus 5, well, I'm getting more negative, so I get negative 13. So we were correct, that is in fact a negative 13 if our graph went far enough to see it. All right, for part B, again, I can't actually see this one on the graph. H of t is 23, but my y-axis only goes up to 10. So I'm not plugging in 23 for t. Instead, I am setting h of t equal to 23. So that means 23 equals, 2t minus 5. And now this is just like what we did in the ready part, the first few ready questions. So now I'm working backwards to solve an equation. So I want to add 5 to both sides of my equation. 23 plus 5 is 28. And then to isolate t, I need to get rid of the multiplication by 2. And again, I always do that using my inverse operation, which is division. So 28 divided by 2 is 14. T equals 14. That's the value that when I plug that into h of t, I get 23. And remember, you could always check your work. Like if you're not sure, something that's really nice about math is you could now plug 14 back in and say 2 times 14 minus 5 is 28 minus 5, which is 23. So we can kind of check that way. All right, we're also asked to find h of 13. So again, I'm not going to see that on my x-axis because the x-axis only goes out to 10 in this graph, but I could still find h of 13 by evaluating h of t for when t is 13. So 2 times t minus 5 becomes 2 times 13 minus 5. 2 times 13 is 26. When I subtract 5 from that, I get 21. So the value of h of 13 is 21. All right, lastly, part D, very similar to what we did in part B. I'm trying to find the value of t that makes h negative 33. So I'm going to set 2t minus 5, my expression for h of t, equal to negative 33, because 2t minus 5 and h of t are interchangeable. So I can substitute 2t minus 5 for the expression h of t. And just like in our ready section, I want to undo the subtraction of 5 with the inverse operation, addition. So now on the left-hand side of my equation, I have 2t all by itself. And on the right-hand side, negative 33 plus 5 is the same as 33 minus 5, except we'll get a negative answer. So that is what? Negative 28. And then lastly, we want to unmultiply. So divide. Remember, multiplication and division are inverses. Divide both sides by 2 to get t by itself. So t is negative 14 there. And okay. All right. Now I can't zoom out. Okay, here we go. Let's do one more for number 9. We are also asked to evaluate and to do some solving, but this time we're not given the function in number 9. So I have the graph of g of x. Remember, g of x is interchangeable for y, and I'm asked to find g of 2. Now, I can do this by figuring out the function. What I could do is I could write my expression for g of x in the form of an exponential equation where b is my y-intercept. Well, my y-intercept is at 0, 1. So b is 1. And g is my growth factor. And so as I move from where t equals 0 to where t equals 1 on my graph, I could see that I am multiplying by 2 because I went from 0, 1 to the point. Oh no, excuse me, I stand corrected. I'm multiplying by 3 because I went from 0, 1 to the ordered pair 1, 3. So since 1 times 3 is 3, my growth factor is 3. So if I'm correct, that should mean that my next ordered pair is 2, 9 if x is increasing by 1 and I'm multiplying by 3. So see 5, 6, 7, 8, 9, and that looks correct. So I could write my equation as g of x, or y, equals 1 times 3 to the power of x, which is just 3 to the power of x. Or I could get my answer from the graph. Either way, g of 2 is 9. I can see the ordered pair on the graph, or I could think of this as g of 2 is 3 to the power of 2, which is 9. All right, so then for part B, similar to before, I'm not substituting 3 for x. Instead, I am solving for x when y is 3. So I could either think about this, what value of x would give me a 3, or on my graph, I could go to where my y values are 3, and I could just find the corresponding x value. So either way we slice it, this happens when x is 1. All right, to evaluate g of 0, again, I could look on my graph for where x is 0, and I see a 1 there. Or I could plug 0 in to my equation, although we had to come up with that equation on our own. 3 to the power of 0 is 1. Oh, part D, there we go. We already did it. That is what we did up here. So the explicit rule for g of x is just 3 to the power of x. All right, I'm going to skip down. We could definitely do number 10. I'm going to skip number 10, and I want us to skip down to 11 and 12. So in number 11, it says two functions are graphed. Graph a new function on the same grid by adding the two given functions. So we have h of x, that's our new function that we're going to graph, and we're told that h is equal to f of x plus g of x. So what I think I might do here is come up with a couple of good x values, and I think I might make what I call an extended table. So what I mean by that is I'm going to put values of f of x in my table, values of g of x in my table, and then we will compute the values of h of x by adding f plus g values. All right, so I noticed that both g and f have, values at x equals -5 that I might be able to look at. But honestly, with g, we have to guess a little bit. That looks like 1/2. I might use where x is 4 instead, -4, excuse me, that would be a -4. I'm just kind of looking at g for where I have some good points. What about at -2? I could see a nice point for both g and f. At 0 would be a good spot when x is 0. Again, when x is +2, it really looks like all of the even values of x are giving us nice clean points on both these graphs. So one way to do this is to write like x is -4, -2, 0, 2, and 4. Let's see, because we don't have to come up with the equation yet. That's the other way we could do this. All right, so I'm going to just look at f, and f is this line, and I can tell that just based on how the graph is labeled. So when x is -4, f is +4. When x is -2, f is +2. When x is 0, f is 0. When x is +2, f is -2. And lastly, when x is +4, f is -4. Okay, we could do the same thing for g. So if this is my equation g, or my graph of my function g, when x is -4, g is on the x-axis, so its y value is 0. When x is -2, g is 1. When x is 0, g is 2. When x is 2, g is 3. And when x is 4, g is also 4. All right, so now if I want to write, or if I want to just graph this new function h, we said h is f of x plus g of x. So I could just add these numbers together. So 4 plus 0 is 4, 2 plus 1 is 3, 0 plus 2 is 2, -2 plus 3 is 1, -4 plus 4 is 0. So 4, 3, 2, 1, 0. So I'm going to graph this in like a bright color so it stands out in the video. If I go to -4, I'm going to go up to +4 on my axis and graph this ordered pair, -4, 4. My next ordered pair for h would be -2, 3. So I'm using the same x values while I'm doing this. -2, 1, 2, 3. Then I would have 0, 2. So 0, 2. Then I would have 2, 1. So 2, 1 on my graph. And then lastly, the ordered pair 4, 0. So the final answer, I know it's a lot of work to get this graph, but my final answer of what my graph of h would look like, I'm going to just use my ruler tool to draw a line. this would be h of x. All right, in number 12, let's do the same thing there, but this time, so first of all, you could do number 12 exactly like I just showed you number 11, but there is another way that we could do this as well. We could do this from the explicit equation of the two functions. So I'm going to show you that method here. It's if you can get the explicit equation, it might be faster. So both of these graphs are linear. So for a of x, let's find the slope and the y-intercept. We could use point slope form here as well. Maybe I'll do that for b since the y-intercept is not super clear. But for a of x, my y-intercept is at 2. So for a of x, I have the ordered pair 0, 2 as my y-intercept, and my slope can be found by just picking another good point and looking at my rise over run. So I'm rising to, running to, 2 divided by 2 equals 1. So my slope is 1. And you can see each time I go up 1 over 1, that point is on my graph for a. So if I write a of x in y equals mx plus b form, that would be 1x plus 2. So this is the explicit equation for a of x. All right, for b of x, we said it looks like that y-intercept is a little unclear. It looks like it might be 1/2, but it also could be like a third. I don't want to guess at it. So what I could do is find a very clear point. And right here, I would say it's pretty clear that the graph of b of x crosses the x-axis when x is -1. So that is not a y-intercept. That's an x-intercept. I could think of that as just a point -1, 0. And if I use point slope form, that's what I'm calling x1, y1. So then my slope, I would need another nice clean point to find my slope. I'm zooming in and it looks like right here when x is +4 that this graph has another point that I can tell very clearly goes through the ordered pair 4, -2. So when I make my sometimes we call this like a slope triangle when we're finding our rise and our run, I'm rising down 2, so my rise is -2. My run is 5 because from -1, I'm moving over 1, 2, 3, 4, 5 spaces, 5 times. So my slope is -2/5. So I could write the equation for b of x in point slope form. So -2/5 times, since this is not the y-intercept, I'm going to say x minus -1 plus 0 on the outside. That's the same as -2/5 times x plus 1. And then lastly, like if I want, I could distribute that -2/5. So -2/5 x minus 2/5. So now we do know what our y-intercept is. It's -2/5. So I would have been wrong if I had guessed that my y-intercept was -1/2. And I could tell it looked a little too close to the x-axis to be -1/2. All right, so now the way we could use the explicit equations for a and b to find s of x to graph it is we could just literally add those together. So we said s of x is whatever a of x is plus b of x. Well, we know a of x is the same as saying x plus 2, and b of x is the same as saying -2/5 x minus 2/5. So that means that this function s with respect to x is x plus 2 plus -2/5 x minus 2/5. And I just need parentheses there because I wrote plus a negative just to be clear. So this is the explicit equation for a of x. this is the explicit equation for b of x. And so this way, might actually be a fair amount harder than I thought. So now we could combine our like terms. We have 1x and we're adding a negative 2/5 x to that. Well, remember, 1 is the same as 5/5. So I could think of this as 5/5 x minus 2/5 x. And then if I consider my constants, I have 2 minus 2/5. If I get common denominators, 2 is equal to 10/5. So this is like saying plus 10/5 minus 2/5. So like the 2 is my 10/5, the minus 2/5 is right there. I reordered those terms just now, but remember, addition is commutative, so it doesn't matter in what order we add. So now we can combine like terms. 5/5 minus 2/5 is 3/5 x. 10/5 minus 2/5 is 8/5 as our y-intercept. And that's the same as saying like 3/5 x plus 1 and 3/5, the mixed number, which would be the same as saying 3/5 x plus 1.6. So any of those work. So for graphing, I think the 1.6 might be most helpful. So if our y-intercept is 1.6 and we are moving up 3/5, it might be helpful to plug in a number. I don't know, this is really tough. I kind of wish I'd done this on the table method. But essentially, we are just graphing this now. So s of x is going to be 3/5 times x, so 3/5 is our slope, plus 1.6. So 1.6 is, let's see, if 1 is here on my graph, 1.5, 1.6 is about there. That's not a great point to start from. So I am finding myself kind of wishing that I'd done this the other way to start with. Maybe a better point to start from would be where we have this nice clean value here at -1 and at 0. Nope, at -1, a value of 0 and a value of +1. So remember, I'm adding those two functions together. 0 plus 1 is 1. So this point is on, that point at -1, 1 is on the graph of s of x. And I could think about that, like that should make sense. If I plug that in, like s of -1 is 3/5 times -1 plus 8/5. So that's like -3/5 plus 8/5. That equals 5/5, which is 1. So that checks out. All right, so we said this graph is on the function, or this point rather is on the function. I'm going to use my slope of 3/5 to fill the rest out. So I'm going to go up 1, 2, 3 over 1, 2, 3, 4, 5 and put a point there. I'm going to go down 1, 2, 3 and backwards 1, 2, 3, 4, 5 and put a point there. Had we done the table method, I think it would have been easier to do on this problem, but I should see that the graph of s goes through these 3 points. So if you use the table method, you would have gotten the same function for s in the end. All right, lastly, in number 13, this should be a little bit easier, I think. We are using the graph to answer the following questions. So where does f of x equal g of x? So we're asked for a location, which is a value of x. So if I look for where the functions f and g are equal, that would be their point of intersection. So we could answer at x equals 2. Because if I look at what's happening at x equals 2, well, f of 2 is 5 and g of 2 is 5. All right, in part B, what is f of 4 plus g of 4? Well, if I come out on my x-axis to 4, it looks like g of 4 is the value 6, and f of 4 is the value 7. So that is like saying 6 plus 7, we get 13 there. Since we said, I did those in a different order. We said g of 4 is 6 and f of 4 is 7. All right, part C, what is g of negative 2 minus f of negative 2? Well, g of negative 2 on my graph, I can tell is, let's see, this is my function g up top. I could tell that looks like I am at 3 on the y-axis. And f of negative 2 is at 1 on the y-axis. So g of negative 2 minus f of negative 2 is 3 minus 1, which is 2. So be careful, the order there matters because subtraction is not commutative. All right, lastly, part D, state the interval where g is greater than f. So I'm going to use interval notation, but I'm just looking for where my graph of g is greater than f. Well, I know that g and f are equal at that point of intersection, and g is the line over here that has the less steep slope. So I'm looking for where g is above the function f, and that looks like that is this part of the graph. So in interval notation, we could write this with interval notation or inequalities, but that's going to be all of the x values for g that are less than 2. So I could just say x is less than 2. I don't want to include the 2 because we already said that add x equals 2 in part A, that's where f and g are equal. With interval notation, this would be from negative infinity to 2, and we would use parentheses because remember we said parentheses do not include the 2, and since negative infinity, it's not a number, infinity is just an idea, I never include it because it's not a value. All right, that is it for the set section.